Hi students. In this lecture, I am going to discuss problems. Let us see first one. A conductor carrying current, it is a constant current, is kept in the xy plane in a uniform magnetic field B. If F is the magnitude of the total magnetic force acting on the conductor, then correct statements are asked in 2015 advance. See diagram. This is now current carrying wire, straight part, then curved, again straight, straight, and again curved, and again straight. Now see options. If B is along Z cap, so here Z cap means it is along positive Z direction. Means in the place of K cap, they have given now Z cap. In the place of I cap, given X cap. In the place of J cap, given Y cap. So you can see wire is now along X axis. And remember, when it is not a straight wire, we have to take between the end points that length, right? So for this entire part, we can take now this length R as a straight part. Okay. See carefully once. So it is given straight wire. Then a curved part like this, and again straight, and again straight, and again curved part like this, and straight. And you can see here these angles are not important for us. Current is I, and this length is L, and this also L, and this is R, and this part also R. Okay. Let us take this is A, and this is B, and this is C. Now we can replace this AB part, with a wire of length AB, because we have learned that if wire is not a straight one, in that case, just replace that with endpoints. So in between AB, just imagine one conducting wire of length AB, right? This length becomes R. Again, replace BC with a wire of length R, straight wire. That means now total length equal to 2L plus 2R. That is our total length. Okay. And given this is x-axis and this is y-axis. Now see magnetic force F bar equal to, it is I into L bar cross B bar. Okay. So here L bar is now along x-axis. So coming to B bar, if B bar is along y-axis or along z-axis, only condition is between these two vectors, if angle is 90, then it is I into L into B. If theta is 90, theta 90 means B bar can be along z axis or along y axis, right? And this is equal to 0 if theta is 0. Its meaning is B bar is along x axis, right? So here I is a constant, B is a constant, remaining is now L. So F proportional to 2 into L plus R, and 2 is a constant, therefore F proportional to L plus R if B bar is either along y-axis or along z-axis because angle is 90. If B bar along x-axis, F equal to 0. It is a very simple and straight question. So you can say options now. B bar is along z-axis proportional to L plus R. B bar along y-axis proportional to L plus R. So both are correct. B bar is along x-axis. F is 0. So B also correct. So A, B, C and D is not correct. Okay. Let us see next one. A charged particle is released from rest in a region of steady and uniform electric and magnetic fields which are parallel to each other. Given electric and magnetic fields which are parallel to each other. The particle will move in since 1999 for 2 marks. So we have decided straight line, circle, helix or cycloid released from rest. Okay. And these two are parallel to each other. It is a very simple one. Directly you can guess the answer also. Let us see. Given both fields are parallel, E bar parallel to B bar. So both are parallel, released from rest. For example, both are along x-axis. Both along x-axis. Since it is at rest, no force acts because of magnetic field. I am repeating. Since it is at rest, no force acts because of magnetic field, but because of electric field, force acts. F bar equal to Q into E bar. If charge is a positive, force will be along the field. If you take both fields along x-axis, there's a particle moves with acceleration along x-axis. And coming to magnetic field, it is also along x-axis and it exert no force because F bar equal to Q into V bar cross V bar. Now velocity is along x-axis, field also along x-axis. So both are along same direction, means the force is 0. That means it follows straight line path. Okay. Suppose in this case, E bar, B bar, both are mutually perpendicular. In that case, path is a cycloid. So which we have discussed in the earlier lecture, right? So option is, it is A. Okay. So circle means only magnetic field and velocity is perpendicular to B bar. Then circle, right? Okay. See next one. Consider a non-conducting ring of radius r and mass m which has total charge q distributed uniformly on it. Given distribution of charge is uniform. The ring is rotated about its axis with an angular speed omega. Find the equivalent electric current in the ring. Find the magnetic moment of the ring. Show that m equal to ql by 2m, where L is the angular momentum of the ring about its axis of rotation. So this question is taken from H.C. Verma. Let us see, given non-conducting ring, radius is r, mass is m, charge is q, total charge, and distribution is uniform. Okay, calculating the electric current, magnetic moment, and angular momentum. Okay. Right. So given it is a ring, radius is r, distribution of charge uniform, total charge q, rotates with an angular velocity omega. Its mass is L. So when it is rotating, charge is now moving because of rotation of the ring. Okay. Even the ring is non-conductor, charge is moving because of rotation of the ring. Okay. They are not moving inside the ring. They are moving along with the ring. Okay. So because of that motion, current is. So we have learned long back while learning electricity, conductivity. In that we have learned current equal to Q omega by 2 pi. So it is a direct one. It is a Q omega by 2 pi. Okay. Next, now calculate magnetic dipole moment, which is equal to I into N into A. So in this case, N value is 1 because this is not a wire. Okay. It is not having number of turns. It is only one. Current is Q omega by 2 pi N. In this case, 1. A equal to pi r square. Okay. So pi gets cancelled. It is now Q omega r square upon 2. Okay. Next calculate angular momentum of the ring about its own axis. So this is equal to I into omega for the ring about its own axis. It is mr square into omega. Now see what we can write. In the place of r square omega, in the place of r square omega, I can write L upon m, right? Substitute there. We get Q by 2m into L. Okay. So just calculating current, then calculating magnetic dipole moment. After that, calculating angular momentum of the ring about its own axis. Then relation between magnetic dipole moment and angular moment. Okay. See next one. And this question asked in 2000 for 2 marks. The same question just now we have discussed. A particle of charge q and mass m moves in a circular orbit of radius r with angular speed omega. It is given a particle of charge q, mass m moves in a circular orbit of radius r with angular speed omega. The ratio of the magnitude of its magnetic moment to that of its angular momentum depends on. So again, same, right? Just now we have discussed. Only change is it is now particle which is moving in circular path. That is the only change. Let us see once again calculation. So it is a particle which is moving in circular path. Radius is r. Mass m, charge is q. Given angular velocity omega. So for particle, when this is moving in circular path, current is given by again q omega by 2 pi current. Next, magnetic dipole moment I into N into A. I value q omega by 2 pi. N value it is 1. Area pi r square. Pi gets cancelled. Q omega r square by 2. Next, angular momentum. For a particle about this axis, I value mr square for a particle. I value about this axis. Omega only. Now, coming to m, in the place of omega r square, in the place of omega r square, I am writing L by m. It is now QL by 2m. Again, same result. Okay. So earlier question, non-conducting ring, and that is ring is rotating, right? It is here particle, but result is same. So answer is it depends on Q and M, right? Because we got Q by 2m into L. Is asking ratio of magnetic moment to that of angular momentum. So option is C, right? Let's see next one. Again, same kind of question, slightly different. Asked in 1998 for 2 marks. Two particles, each of mass m and charge q, are attached to the two ends of a light rigid rod of length 2r. Now only change is having two particles, each of mass m charge q, attached to the two ends of a light rigid rod, length is 2r. That means what we can say here, each particle is a following circular path of radius r, right? Next, the rod is rotated at a constant angular speed about a perpendicular axis passing through its center. The ratio of the magnitudes of the magnetic moment of the system and its angular momentum about the center of the rod is. So again, same question. So same calculation. C once. So having here two particles which are connected to the two ends of a light rod. Two ends of a light rod of length 2r. This is now rod. Length 2r. This is r. This is r. So 2 point masses cm and m. Charges each q and q. Following circular path. Right. So first of all, calculate current. I equal to q omega by 2 pi. Right. Q means 2q. Omega by 2 pi. That is equal to q omega by pi. Right. Current. Next, magnetic dipole moment. It is I, N, A. I value Q omega by pi. N is 1. A value pi r square. So pi gets cancelled. This is a Q omega r square. Right? Next, coming to angular momentum about center of circle for one particle m r square into omega for both. So into 2. Now write in the place of omega r square. It is omega r square. It is L by 2m. So Q into L by 2m. Again, result is same, right? In these three questions, question is almost same, slightly modified. Okay. So answer is now, it is option A, right? Q by 2m, right? Let's see the next one. H plus, He plus, and O2 plus, all having the same kinetic energy, pass through a region in which there is a uniform magnetic field perpendicular to their velocity. The masses of H plus, He plus, and O2 plus are 1 AMU. AMU means atomic mass unit. right? 4 AMU and 16 AMU respectively. Then he's asking which one deflects most, right? H plus, He plus, and O2 plus. Condition is given that with the same kinetic energy, 1, 4, 16. Let us see how to decide deflection is more or less, right? Asked in 1994 for 2 marks. Right. See how to decide that. We know radius equal to mv by bq, or in terms of kinetic energy, 2mk upon bq. Okay. Now imagine a particle is moving in a straight line. It is moving in a straight line. So what is now deviation? Moving in straight line means there is no deviation, right? And remember, straight line means what is radius? Straight line, R value is infinity. Am I correct? Straight line, R value how much? Infinity. That means if R is more, deflection is less. I am repeating. If R is more, deflection is less. Okay. Because here, infinite means straight line, means no deviation. Straight line means R is infinity. That means R is more, deviation is less. R is less, deviation is more. That means we have to focus regarding the radius of the circular path. Okay. So from here, see what we can say. Given K same, for all B same, remaining is their mass and charge. So R proportional to root m upon q. So given which particles H plus, He plus, O2 plus, right? Then see what we can do here. I'm taking ratio R H plus, R He plus, R O2 plus, root m by q. Mass, it is 1. Root 1 is 1. Charge, I'm taking as 1 unit. It is 1 unit. Coming to helium, He plus. Again charge. Charge is 1 and mass is 4. Root 4. Root 4. Root 4. Charge is 1, right? He plus. Okay. Coming to oxygen, 2 plus. Charge is 2. Mass is given 16. So root 16 upon charge is now 2 units. It is 2. So 1 is 2. 2 is 2. Root 16 means 4. 4 by 2. It is 2. That means H plus is having least radius. R is least means deviation is most. Okay. Deflection is most. Right. Coming to He plus and O2 plus, R value same. R value same means deflection is the same. Okay. So here what we have to remember is radius is more, deviation is less. Radius is less, deviation is more. Now see options. So H plus will be deflected most. It is correct. Next, He plus and O2 plus will be deflected equally. So this also correct. So options are A and C. Okay. So I hope you got clarity.